All right, well, let's do another example. Using our division algorithm, we want to express the solution to the division x to the fourth plus 2x cubed minus 56x minus 3 divided by x minus 3. So we're going to use that division algorithm right here. We're going to put it in synthetic division here first to start off with. So our division algorithm setup tells us that when we set up our division bar, we're going to put positive 3, right? X minus 3 is equal to 0 at x equals positive 3. And our coefficients from our dividend right here of 1, x to the fourth, 2, x to the third, 0, x squared, negative 56x minus 3. And the result from that minus 3 right there, that's going to be our remainder. So I'll put a little bar right there. That's what I always do to remember it. Bring down the 1. Multiply by 3. Add down the column. Multiply by 3. Add down the column. Multiply by 3. Add down the column. That's negative 11 in this case. Multiply times 3, so we get negative 33. Add down the column, so we get negative 36. And what have we found? What we found by this division algorithm right here is that p of x, x to the fourth, plus 2x cubed, minus 56x minus 3 is exactly equal to x minus 3 times, from our quotient right here, we divided by x minus 3, so we're going to get x to the third plus 5x squared plus 15x minus 11. That would be added to our remainder of negative 36. So I'll just write minus 36 right here for our purposes. P of x. This is P of x right here. We have sort of an interesting note right here. This is something called the remainder theorem. Now, I don't know if you remember the remainder theorem, but it stated that if we divided a polynomial P of x by a quantity x minus c, the remainder we get is actually the value of the function at x equals c. So what does that really mean? Well, if this is P of x right here, what happens if we find P of 3? Well, we could take 3 to the fourth plus 2 times 3 to the third minus 56 times 3 minus 3 and calculate our result. But watch what happens when I put 3 into its equivalent. I'm going to get 3 minus 3 times 3 cubed plus 5 times 3 squared plus 15 times 3 minus 11 minus 36. By the way, in our notation right here, we had P of x as x minus c times q of x plus r. P of x is x minus c times q of x plus r. But we substituted in c, and look at what happens right here. C minus c, well, that's 0. It doesn't matter what happens to all the rest of this. We could calculate it out if we wanted to, but we're just going to be left with 0 minus 36 as a result. And so P of 3, by the remainder theorem, is equal to negative 36 in this particular instance, as an example. And so now we've just found that substituting in this number into our dividend polynomial results in a remainder that's equal to the value of the polynomial at x equals c. That's what the remainder theorem states. If a polynomial p of x is divided by a quantity x minus c, the remainder itself is the value of the function evaluated at c. The function P of x equals x to the fourth plus 2x cubed minus 56x minus 3, evaluated at x equals 3, is equal to negative 36. Very quickly. And that's one of the nice things about the synthetic division, is that we can use it to carry out a quick calculation on a polynomial. More to come.